So let's take a look at our warm-up. We are doing substitution today, reviewing substitution, which was 7.2, and then we'll review 7.1, and then 7.3 and 7.4, which were both elimination. 7.1 was graphing. So substitution is another word for replacement, if I can spell. Means we're replacing something with something else. So we know we need x or y by itself, and we're going to replace that letter with whatever it's equal to. So this one we have y by itself. Y is really equal to 6x minus 1. So in my other equation, whatever equation we have there, anytime I see the letter y, I'm going to replace it with 6x minus 1. So I'm just going to rewrite this equation. It says negative 3x plus 2y equal to 7. Oops, I already made a mistake. Instead of the letter y, we're replacing it with 6x minus 1, all equal to 7. So I took out the letter y and replaced it with this piece here. Now we're going to solve this. First, I'm going to draw my box so I can distribute. 2 and then 6x minus 1. 2 times 6 is 12, so 12x. 2 times negative 1 is negative 2. So let's rewrite what we have. We have 3x, it's negative 3x. We're done multiplying those, so we have plus 12x minus 2 equal to 7. So next we have two terms that have an x. So a negative 3 and a positive 12, or just 12 minus 3 gives us 9x minus 2 equal to 7. And then if we continue here, opposite of subtracting is adding 2. So we're left with 9x equal to 7 plus 2, which is 9. And then last, the opposite of multiply is divide by 9. So 9 over 9 is just 1. So we have x. Remember, every answer we have in our test is going to have an x and a y. We know x is 1. So we can plug that back into either equation to get y. Now, which equation would you like? Doesn't really matter. I like the second equation better because it's already solved for y, and that's what I'm trying to figure out. So it says 6x, but x is really a 1, minus 1. So 6 times 1 is just 6. So we have 6 minus 1, which is 5. So I know y down here is 5. That's where my lines would cross if I were to graph them. The first is 7.1, solving by graphing. And the second is 7.3 and 7.4, which is solving by elimination, which is most people's favorite, the ones that we worked on most recently. So first, solving by graphing. If they give us two equations, let's say we have y equals 2/3 x plus 4. And let's say the other equation is 2y equals negative x. We would need to solve these for y to get the form y equals mx plus b so we can graph them. This one is already in that form. I know m is 2/3 and b is 4. Remember, b is where we begin, so I would begin this graph at up 4. And my slope m is how we move. Rise over run. So I would rise 2, 1, 2, and run 1, 2, 3. Or the opposite, down 2 and to the left 3. And I changed this equation over here so that these actually cross at a nice number. But they'll give you the two equations to start with. So we were going up 2 and 3 to the right, or down 2, 3 to the left, down 2, 3 to the left. And we can draw our line through there first. The second line, we would need to solve for y. So I would have to divide everything by 3. 3 over 3 is just 1y or y. This would really be a negative 1x. So we have negative 1/3 x plus 3 over 3, which is really just 1. So this is also now in the form y equals mx plus b. So I know b is 1 and m is negative 1/3. So we're beginning at 1, positive 1, on our y-axis, and we're going down 1 and 3 to the right. down 1, and 3 to the right because we had a negative 1 over 3. Rise up and down first, then run left and right. Instead of going down and right, we can also go up 1 and 3 to the left. Up 1 and 3 to the left. So if we draw our line through here, we have this as our solution. It's going to ask you for a solution. You need to list it as a point x comma y, just like we did for our last problem. X, going left and right, we went negative 1, negative 2, negative 3. And then on our y-axis, we're up 1, 2. So that would be our solution. The second part that we needed to review was called elimination. This is when we have two equations. For example, we might have 2x minus 3y equal to 8 and 5x plus 3y equal to 10. If we have our x's or the y's the same number, we can add or subtract. This one is set up to add because negative 3 and positive 3 will eliminate. So we would add these and get 7x equal to 18, and we'd have to solve. Once you get x, you would have to plug it back into one of the equations for x to find y. Doesn't matter which one. Same thing for, I'm going to erase part of this for now. Same thing if we had two other equations. What if we had 2x plus 5y equal to 20 and negative 6x plus 8y equal to negative 15. Neither the x's or the y's are the same number, so we would need to multiply one or both of the equations to make the x's or the y's the same number. 5 times nothing is going to give me 8, but 2 times 3 would give me 6. So if I multiply everything by 3, both of the equations will have a 6 in the x spot. We need one to be positive. This will end up positive, and this is negative. So we'll have 6x, 5 times 3 is 15y, and 20 times 3, 2 times 3 is 6, so that's 60. The bottom equation I would just rewrite. And then we would add our equations together just like we did before. These two would eliminate. We would add these. 15 plus 8 more give us 23y. And 60 minus 15, 50 would be 45. These aren't turning out to be nice numbers because I just made them up. But once we solved, we'd have y. And once you have y, whatever number that is, you can plug it back in to one of your equations to find x. So I would pick an equation and write 2x plus 5 and then whatever number y is equal to 20 and solve that. I know we're running into our other problem here, but you get the idea. Hopefully this one's the freshest in your brain because we did it the most recent. Otherwise, good luck on your test. You can only use your calculator and your notes. Good luck.